f for the antiderivative, and the lowercase f would be a function that you're starting with. But for the way you guys were already thinking about it, the f right here would be like a derivative you found, and an antiderivative would be you working back to the original. So for that, like the first problem that was just up there was this, but like for the first problem that we had, I started you here and said find the first derivative, whereas now today they'll say start here and find out what the original function is. This idea, all this top one says is that if you do an antiderivative of a function and there's a number out in front, like multiplied by it, the number just kind of tags along with however many antiderivatives you do. So this one we'll use. This one right here would be directly related to something raised to a power. And again, this is like the start, and this would be like the antiderivative of it. So the biggest difference is now you're not subtracting one from powers, you're adding it because you're wanting it to go backwards, back up instead of down. So this one, like I said, e to the x, and then cosine and sine. The rest of them we're not really going to run into because you don't have to do secants or tangents or anything like that. So these rules will be the only ones that we work with in terms of doing these problems. Like I said, if you look at it, it reads a little weird. But what it's saying is you take whatever you're starting with and break it down into, in this case, 3 separate functions. So just like the derivatives, you deal with each one separately when it's added or subtracted. So when it says x to the n goes to x to the n plus 1 over n plus 1, it's saying take whatever's there. Now, this x to the n is solely focusing on this, right? This 8 out in front would count as like a c, but by the rules of this, anywhere there's a c, that's always going to exist. So like the 8 would just carry along in terms of my antiderivative here. But like this rule right here is only going to apply to this part of it. Okay? So when I write my antiderivative, like I said, the constant is going to follow along. This rule says take whatever the power is, add 1 to it. So 9 plus 1 would be 10. And then whatever this becomes up top, you just put below it. So that would be your antiderivative for 8x to the 9. Okay? So over here again, the 3 right there would be your constant, so the 3 comes along. The n, in terms of that power, would be 6. So 6 plus 1 would be 7. Whatever number you end up with after you add 1, you just drop it to the bottom. Okay? That's pretty much it. So again, 12 is the constant, so you want to put that there. The power there is 3. You add 1 to it, you get 4. That number goes to the bottom there. The only thing you would have to do once you're there, guys, is reduce fractions. If things divide out evenly, divide them out. Okay? Oh, and also plus c. Sorry. Okay? So like 8 over 10, don't leave it as 8 over 10. Put it as 4 over 5. And you can write it probably as a fraction if you want. If you want to leave it as 4x to the 10th over 5, it's fine. It's the same thing. 3 over 7 doesn't reduce. So that stays. And then 12 divided by 4 is 3. So this would be what's considered the most general antiderivative for the original function. Okay. So again, just like before, I got the 2 rules that we're going to use at the top. And again, the rules apply as if the constants are there, but by what I had in the big chart, anything that's a constant is just going to kind of tag along. Like when I do the rule for the first part for my antiderivative there, since there's a 3 in front of the e to the x, when I start this, I'm still going to put the 3 there. It's not going to go away. Okay? And then once you deal with the constant, the rule will apply to whatever is after that. Like this is e to the x. So since the derivative of e to the x is e to the x, the same thing applies for antiderivatives. So e to the x ones are easy. They literally don't change. You guys aren't going to have any that have powers into it, so you don't have to factor those things in. At least not right now. Maybe you will later. Then down here, again, the constant out in front stays there. You apply the rule to sine x, which for sine x, the antiderivative, as it says up there, is negative cosine x. And I just wrote it that way just so I have it separated as constant and then what the antiderivative is. And then plus c at the end. And then just make sure it looks nice and neat. Like instead of writing plus 7, just change it to minus 7 cosine x plus c. So when you write the first one, like the fourth root of x cubed should become x to the 3/4. And cube root of x to the 4 should become 4/3. Because then once you got that, you just apply the rule that we did on the first one. Where now you got an x raised to a specific power. So when you do the antiderivative, you'll have x to the 3/4 plus 1, which 3/4 plus 1 should give you 7/4, yes? Okay. So 7/4, and then in your denominator, that exact thing needs to go. So whatever the power is still goes right to the bottom. All right, and then the other one, so 4/3 plus 1, 7/3. And again, the thing on the bottom has to be identical because, again, if I took the derivative of it, I want it to kind of go away. So this power and that power are going to cancel each other out. And then just like before, I wouldn't leave it that way. I'd want it to be fully simplified. So instead of writing it as like a fraction with a fraction underneath it, I want this now to become 4/7, right? Because I'm dividing by a fraction, which is the same thing as multiplying by the reciprocal. Okay? 7/3 plus c. But the way you start this, it wouldn't be any different than the way I just did those other ones. In this case, they want you to find the function. They tell you the derivative. So if you want to keep it with the notation we just had, this would be the little f of x, and the same find the capital F of x, but it's the same kind of concept. So if you want to write it that way, that's fine. So they got 2x to the first. All right, so the first thing I would do is I write them all so it's like a variable raised to a specific power, so then I can apply the rule that's up there to it. So if you want to keep this in the same notation we just had, this would be like the f of x, and I'm trying to find the capital F of x. Okay? So the original function from the derivative is what you're working towards. So for this one here, again, it's add 1 to the power, right? The 2 is a constant, so the 2 kind of just hangs along. Add 1 to the power, and then that power now goes in the bottom. The 3, again, is a constant, so it goes along. Here I got -4 plus 1, which is -3, correct? Okay. And then this power now goes in the denominator. And then it'll be plus c. So if I simplify that, or like divide out things I need, that'll become x squared there. And this will be a +1, x to the -3. Or if you want to write it as that's fine. Okay. Now the reason in this case I can actually figure out what the value of c is because they tell me that for this function I just found, I know that if I take 1 and plug it in place for x, I will get a value of 3. So that part right there is just telling you, look, take 1, plug it in for x, like here, so that it becomes 1 squared plus 1 over 1 cubed plus c. And they're telling you what to set this equal to in order to figure out what c is. 3. So if they tell you all this, this would be a case where you don't want to stop here. You want to actually be able to figure out what the constant value is. So 1 squared is 1. 1 divided by 1 is still 1. So that's your equation. So C should be 1. So your final answer, after you do all this stuff, so this part would be getting the general antiderivative. You would then take that, plug in the value of x they tell you, set it equal to what it should equal, which is, again, something they would have to tell you. Do a little bit of work to get C. And then once you're there, you would take this C value and replace it. So that would become the final answer. If they don't tell you this portion, though, you can't find C. Like, they have to give you something. They have to tell you what the value of the function is at a specific x value. Right? No, there's one other one I gotta do. Okay, and look, one other type of problem. Okay, this one is still general. Like, I'm not gonna, you're not gonna be like, C is gonna be your answer here. The difference between this one and the other ones I've done is now you're starting at a second derivative and working back, which means we have to do 2 antiderivatives to get back to the original. All right, which means when I write this out, I'm actually going to have 2 constants in it. But for rules that you use, this one still should be pretty straightforward because it's just powers. Okay, so here's the other thing, and we didn't do one with just like started with the constant yet, did we? No. I don't think so. But if you remember, like, the only way I can get a value that's just a constant in a derivative is if right before that, so like to get here, this is 1 antiderivative to get back to the first. So I'm going from the second to the first derivative. To get it to this point, I would have had to have a variable there because the derivative of 2x is 2. This would be the one case where this is technically like x to the 0. It's just not written that way. Okay? All right, so first antiderivative here. 3 plus 1 is 4, correct? 4. 6 plus 1 would be 7. Over 7 plus 6. Okay? So that's first. Since the question has asked me to go back to the original function, not a derivative of it, that means that I now have to do another antiderivative. But in this case, now I'm doing it of the function I just found. Okay, so that means C is going to be this answer plus another variable, which they'll just use D for the other constant.
Do we simplify the first derivative first?
Well, it kind of is. I don't have anything to reduce. If you want to write this as 1/4, you can, but I don't really need to. It might be, well, you know what? We'll do it that way. Okay. Like, that might be an easier way to look at it since we're doing another one. All right, so again, I'm going step by step, right? 2 is a constant, so that's still there. That's x to the first, so if I add 1 to it, I get squared. And then that power drops through the bottom. 1/4 is my constant. So 4 plus 1 would be 5. And now that new power goes down to the bottom. Again, 1/7 is my constant here. 7 plus 1 is 8. That drops to the bottom. Just like when we started, right, when I went from 2 and we did the antiderivative of 2, it becomes 2x. Since C is technically a number, you treat it the same way as I treated the 2 up there. So when I do the antiderivative of C, it becomes Cx. And then I also, now since I've done every antiderivative I do, I have to add a specific letter for a constant on there. So we'll do D's the next one up.